we're going to take a look at being able to find the inverse function for a number of other types of functions. And these are a little more difficult than some of the ones we've seen so far. So we have this x squared plus 1. And remember, the first thing that we should do is graph the function to see if it's 1 to 1. All right, so we have our x squared plus 1. So we have y equals x squared plus 1. All right, I'm going to zoom out a little bit. And let's just plot the line like y equals 2. And I want you to notice that it clearly fails the horizontal line test because we have 2 points right here that clearly intersect the horizontal line and the function simultaneously. All right, so if a function does fail the horizontal line test, this is the graph of the function, just illustrate that it does. Okay, so this fails the horizontal line test, so there is no inverse over the domain of this function. All right, so now if we limited the domain, that there could be an inverse, but there's no inverse over the domain of this function. And I'm going to put a side note here that there is an inverse over the interval where x is from 0 to infinity. All right, but we're not asked to find that. We're just asked to find the inverse of the entire function. All right, so just want to make sure that we understand that if we limited the domain, there could be an inverse. In fact, there is an inverse. All right, but just because we haven't limited that domain, then there is no inverse. All right, another example. So we have this x to the 5/3 minus 1. All right, so let's graph that. So we have x to the 5/3 minus 1. All right, and let's zoom out a little bit. And yeah, it looks like that if I was to select a number of horizontal lines, even y equals 0, all right, it looks like, and then down at 1, excuse me, or -1, excuse me, it looks like that we have exactly one intersection in all these horizontal lines. Okay, so we would just say for this one, for part I, that we say yes, seems to pass the horizontal line test. Okay, so that's good because that means we can at least try to find the inverse of this thing. And so now what we're going to do is we're going to go ahead and remember we replace the function name with y. So we have y equals x to the 5/3 minus 3. We're going to solve this. We're going to interchange the x and y variables. So we have x equals y to the 5/3 minus 3. And then finally, we're just going to add 3 to both sides. So now we get x plus 3 equals y to the 5/3. Now this is the tricky part. To undo a 5/3 power, all right, how do we do that? Well, what we're going to do is we're going to take the 3/5 power of both sides. And what that's going to do is that's going to cancel the 5 and the 5 and the 3 and the 3, and that's just going to leave us with a y. And so this becomes an x plus 3 to the 3/5. And then the last thing we do is we just replace. So we say x plus 3 to the 3/5. And we're going to replace with an I to the -1 of x. So that's our inverse function. Remember, we can always verify geometrically that these are inverses, or we could just stick the function back inside of the function to verify that. Now, we're not going to do that in this example just because we've done it so many times, all right, that we could probably see that the 5/3 power and the 3/5 power would take care of each other, and then the plus 3 and the minus 3 would take care of each other. So just upon initial inspection, it looks like that, yeah, they are inverse functions. All right, now, these last two examples are pretty tough, all right? So we want to find the inverse of each one-to-one function below. And this one, we already know it's 1-to-1, all right? It tells us that it's 1-to-1, so no need to graph it. First thing we're going to do, let's replace the b of x with y. So we're going to have y equals x plus 1 divided by x minus 2. Then what we're going to do is we're going to interchange all the x's and y's. So we get x equals y plus 1 over y minus 2. And now we have to solve this for the y variable, which is tough because if we look at this, there's two y's in this example, and in all the other examples, there's only been one y. What I'm going to do to start is I'm going to multiply both sides by y minus 2. All right, that's a pretty common technique when we're solving equations to be able to multiply through by the least common denominator. All right, and so if I do so on the left-hand side or the right-hand side, the y minus 2's are going to cancel. But on the right-hand side, we have x times y minus 2, and then we have y plus 1. All right, so we still have two y's on the left-hand side. We don't want to do this usually, but in this case, we are going to distribute the x. So we get xy minus 2x is going to be equal to y plus 1. Now what we're going to do is we're going to get all the terms that contain a y to one side. All right, so you might remember, anytime that you solve an equation, you always want to get all the variables to one side. And so what I'm going to do is I'm going to add 2x and I'm going to subtract y. So this gives me xy minus y equals 1 plus 2x. Okay? Now here's the tricky part. These both have a y in them and they're on the same time. So what I'm going to do is I'm going to factor out the greatest common factor of y. That's going to leave me with x minus 1. All right, and if you don't trust that factorization, you can always just go through and try to distribute again. So that's going to be x minus 1 times y is 1 plus 2x. Now at this point, we're going to divide both sides by x minus 1. And so we get y equals 1 plus 2x divided by x minus 1. Or remember the original function's name was b. So this is going to be, no pun intended, b minus 1 of x is 1 plus 2x over x minus 1. All right, and that's it. So key steps in this, okay? Making sure that we multiply both sides by a common denominator, which is y minus 2. And then once we do that, we have to distribute, try to get all the y's to one side, and then we have to do a factorization. Okay, so this one's a pretty tough one. A lot of algebraic techniques to be able to solve this for the y variable. All right, we do have one more example of this. This might be a good time for you to pause the video and see if you can find the inverse of this function, and then maybe start the video up once again once you get the answer to see whether you are able to do so or not. All right, so I'm going to go ahead and work through this. First thing we do, we replace t of x with y. So we have y equals 4 minus x divided by 2x plus 3. Then we're going to interchange all the x's and y's. So now we're going to get x equals 4 minus y divided by 2y plus 3. Remember the trick. We're going to multiply both sides by the common denominator, in this case 2y minus 3, or 2y plus 3, excuse me. So we're going to say 2y plus 3 and then 2y plus 3. The 2y's plus 3 on the right-hand side cancel out. And then on the left-hand side, we're just going to have x times 2y plus 3. So x 2y plus 3 is equal to 4 minus y. We're going to distribute the x just like we did in the previous example. So that gives us 2xy plus 3x equals 4 minus y. I'm going to subtract 3x and I'm going to add y to both sides. So this gives me 2xy plus y is going to be equal to 4 minus 3x. Remember that trick, we're going to factor out the greatest common factor of y from both of those. So we have y times 2x plus 1 is going to be equal to 4 minus 3x. Second to last step, we divide both sides by 2x plus 1. So y is going to be 4 minus 3x divided by 2x plus 1. Remember, the original function's name was t. So now we replace with the inverse notation, and we have t minus 1 of x is going to be 4 minus 3x divided by 2x plus 1. All right. Depending on your algebra, just letting you know, another way to try to rewrite this expression, and by the way, this is a good answer, there's nothing wrong with that answer, is to multiply the numerator and denominator by -1. And that might help sometimes to be able to clean up the expression. And I'm only saying this because there are some times where you get a lot of minus signs. So This is completely unrelated, but let's say we had this expression of -1 plus x over -5 minus 3x. What we could do is we could multiply the top and the bottom by -1, which is completely legal, and that would give us 1 minus x on the top, and then on the bottom, that would give us 5 plus 3x. Okay, so another way to write this would be to change all of the signs, and we could write this as -4 plus 3x divided by -2x minus 1. And these two are the same function. Okay, there's nothing wrong with either of those. But the latter of the two is a little bit more complex. And so it might be easier sometimes if you were to multiply, just like we did in the previous, both of those by -1, and that would turn it back into 4 minus 3x divided by 2x plus 1. Okay, so anyhow, that's a little bit beyond the scope of the answer. However, that is going to be useful in the remainder of the course when we start doing some more complex sort of algebra problems. All right, so that's everything for inverse functions. We have one more section in chapter 1, and that's where we're going to be taking a look at the midpoint formula, the distance formula, and then equations of circles.